My name is Chris Adams, and I first started working with Django in 2008. But over the past 10 years, I've also worked as a designer, a system administrator, a product manager, a UX consultant, and a user researcher on various environmentally minded projects and startups. I currently live and work in Berlin, and I booked a train down here with one company I started with. And I'm working with Mondo at the moment using Django to basically improve how we heat houses in places where it gets cold. My aim today is to provide you with some context. Sorry, I'll start again. Over this time working on all these projects, I've been thinking a fair amount about how what we do as developers relates to the wider discussion about the environment and climate change taking place. So my aim today is to provide you with some context for how what we do fits into this picture and share a mental model for thinking about building apps with this in mind, and also share some examples of how this might relate to your work. So I'm just going to make sure we're all on the same page here. And I'm going to be mentioning carbon dioxide a few times today. So I'm going to start with just a brief primer on the greenhouse effect. So we've got the sun here. Sunlight hits the Earth, which ends up warming the planet, which is good. Then some of it bounces off, which makes the planet visible. But what's special about Earth is that we have large quantities of certain gases within the atmosphere, primarily CO2, which bounce energy back into the planet. So this energy warms up the planet, and we refer to these gases as greenhouse gases. And this phenomenon we call the greenhouse effect. So the greenhouse effect has been very, very useful to us. It's what made life possible in the first place. But over the last, say, 100 years or so, largely as a result of human activity, we've ended up with greater levels of greenhouse gases, and in particular CO2 in the atmosphere. So more CO2 results in a more powerful greenhouse effect, resulting in more energy in the system and a warmer world. And a warmer world does sound kind of nice, right? Like you look outside and it's like lovely and warm, right? But the reality is somewhat less nice. The reality is more like extreme weather events, more drought, more destruction to vital ecosystems that we rely on. And in general, problems of the kind that scientists describe as existential threats, and ones that can only really be solved by collective action. So, since the mid-90s, we, and by we, I mean all the countries making up the United Nations, have been meeting every year for a series of huge meetings to agree on what to do about this. And this aforementioned existential threat to our civilization. And finally, after 21 goes at getting this right, in 2015 in Paris, more or less everyone agreed that we definitely want to limit climate change. And we want to aim for less than 2 degrees of global warming in total. And this effectively created a ceiling on the total amount of greenhouse gases that we can emit as a planet. A carbon budget, if you will. So if we want to stay inside this budget, our emissions that we kind of see here, this graph here, they kind of need to do something a bit like this. So when we get to blue, we're safe. And so round about, like, say, in 2030s, we need to be kind of zero, very, very, very close to zero, just stand a chance. And getting an agreement like this in Paris is quite impressive, but what's even more amazing is that people are actually following through with this agreement and changing how their economies work now. So according to the International Energy Agency, 2017 was the third year where global emissions didn't increase, but the global economy grew. So we're seeing a decoupling of economic growth from emissions. So we can now point to this happening in America and in China, the two largest emitters as they move away from coal, while their economies still grow. So this is a good thing. That said, though, before we start feeling too proud of ourselves, we do need a sense of perspective. Because it's taken this long to reach this turning point, as a civilization, we need to reduce our emissions much more aggressively than we did a few years ago, especially if you want to stay within 2 degrees of change. So this blue line here from the 90s shows the kind of gentle progression that we would have had before. But because of our inaction, we've got this red line now, and as you can see, the further we wait, the more aggressive we need to actually drop our emissions here. So we've established now that we can change our economies, and we need to have a lot to do, and we need to do it fast. So where do we actually start? Now, I apologize for this daunting graph here. This is a Sankey diagram from 2010, and this shows a rough breakdown of global emissions by basically sector and the source of emissions, and also the kind of greenhouse gases that come out here. Now, the bit on the left, which is the key source, and the bit in the middle shows the emissions by sector, right? So you can think about it like these are the sectors responsible for this. So you've got like transport, you've got residential buildings, you've got agriculture, and so on. So agriculture, which is like, food and stuff, that's like, say, 7%. And transport is, well, road transport is about 10% inside there. And you can also see that, say, there's a thing called land use change, which is basically deforestation. That's like 15% of all the emissions, right? And also, if you look inside there, you can't see it very well, and I do apologize, but we can see flying there, which is about 1 or 2% of global emissions. So we can see that IT doesn't even show up. So why are we even talking about IT? And this is the key thing. If you woke up tomorrow and said, I really need to change something about how, and do my bit about climate change, you're not going to think about saying, well, okay, I'm going to start with changing how I design websites. That's not going to convince anyone. But there are important discussions we'd probably have about our diets, like how much meat we eat, or how we keep our homes kind of warm or cool, or even how we actually travel around, like flying or going or commuting by car, all these things here. However, I'm not here to talk about that because it's far beyond the scope of the time I have. So instead, I'm here to talk about the impact we have when we build things online. So this deck here is citing the Climate Group's Smart 2020 report, which shows IT at around, say, 2% of planetary emissions in 2007. So that's about the same as aviation, all right? So, and do you remember how much power generation was using yesterday in the last slide? So I think it's, energy supply, this one here, 13%, right? That's, as an industry, we're getting pretty hungry. Like, we're part of that because we are one of the big users of electricity. And like, to give you some perspective, I live in Germany. Germany is the 4th largest economy on Earth, and Deutsche Telekom is the 3rd largest consumer of electricity. So with all that heavy industry, the telecom company is the big user of energy. And in 3 years' time, if we refer to this report, we can see that we're going to be like twice the emissions of aviation, so we're growing really fast. So we may have started small, but we're growing fast, and as web developers and developers, we might not have direct control over deforestation, but we do have rather more control over how we might use data centers and the infrastructure for shipping bits and data to our customers. So as I said before, I've been trying to come up with a mental model to help me think about, take this stuff into account when I'm building websites or apps. And I'm going to share it with you today. And I'm doing it because I think there's a lot of overlap between what's good environmentally and what's good practice when building digital products. And I also think that if you want to bring about the change that we need, then framing it in positive terms, like being awesome at your profession, is a much better approach than trying to shame people into action, because we've seen this not work for the last 40 or 50 years. So I've kind of organized this mental model into 3 main areas, right? So your platform, your packets, and your process. And these are, in each case, I'm borrowing from existing communities of practice that don't always speak to each other. So your platform, we might be borrowing ideas from software engineering and technical architecture and the DevOps movement. So this is like your own servers. So your packets, that's like sending data to people, like the packets you send along. So we might be borrowing ideas from, say, web performance optimization. And your process, we kind of borrow ideas from like the lean UX movement and people working in continuous delivery. So things like that might be how you do research. Like, are you able to have lightweight approaches rather than having to fly to see someone? How much do you actually build before you decide whether you want to continue with the project or not? That's kind of your process. And I won't have enough time to talk about it today, but there is a 45-minute long talk that I gave in November that at the end of this deck that I can share with you. So let's talk about your platform. So when it comes to servers that you control, you can think of there are 2 ways where you create some kind of impact. So it's who your providers are and how you provision your computing power. So when we talk about providers, we talk about how the electricity powering your service is generated. And this is probably where you have the most direct control. So a few years back, if you wanted to run your apps on green power, you need to run them in Iceland, where almost everything runs on clean geothermal power anyway, or you'd have a small number of providers who weren't very reliable or had very, very limited product offerings. So these days, though, things are better. Like, you're much less likely to make this trade-off of green and effective these days. And in Europe, at least, if you're using, say, Amazon or Google, then you're already, because they claim to run on renewable energy already, you've already made a decision which actually reduces your impact quite substantially. And also, given like it's Amazon and Google, you have a lot of very, very useful products and tools to help you build good services without giving away too much of a competitive advantage. The other thing, once you've spoken about how you source power, is how you actually use these resources, how you provision them, all right? So you can think about, I think one way of thinking about this is actually to look at this graph here. So this is the graph from the CET report, which is the Commission for Energy Efficient Technology. I can't remember what it is, but I'll refer to it in a second. But this is essentially how the internet, how everyone uses the internet, right? So you can see that most of us are asleep. We don't tend to use the internet when we're asleep that much. Then we all go to work, so we start using it more here. Then at the end of the day, we all go home and watch Netflix, all right? So that's kind of the graph of usage, right? And for many of us, when we're responsible for running services, we have often got used to paying for compute by the month. So we don't really think about the capacity beyond whether we've reserved enough to deal with the spikes. So we just want to make sure that we've got enough reserve capacity and we can handle the headroom, and that's the end of it. And if we're thinking about the environmental impact of this, I think that's a missed opportunity. It feels a bit like kind of leaving the office lights on at work when you go home, especially when you think about how people tend to use lots of the applications we build. So Adrian Cockcroft, he's now kind of cloud supremo at AWS, and one of the key people behind Netflix is moved to the cloud. Yeah, he's basically saying, look, we've got nearly 170 hours, and and people are only using it for about 25, 30%. So the rest of the time, we're essentially burning money and burning CO2. And for a long time, that's kind of been considered okay, because provisioning servers has been slow, has been hassle, and it's usually been cheaper just to leave the lights on rather than think about actually scaling things up and down. But as we've started to use services more than servers, this has changed. So as we shift to things like platform as a service, like Heroku or OpenShift or, Cloud Foundry and App Engine, we trade a higher unit cost for per unit of compute for greater ease of management of these resources. So if we're looking at this through a kind of planet-friendly web lens, we might care about scaling down during periods of low use, so we burn less compute and therefore less CO2 and also less cash. So increasingly, you can do this in response to heuristics about load and response time. So, and if that sounds a bit like voodoo to you, you can also just use things, just turn things off when people go home as well, but based on looking at previous usage patterns. And I'll touch on this later. The other thing that we actually have is like functions as a service. So this is another model of actually computing that we have these days. So rather than paying per application, you pay per response. So you don't pay for any reserve capacity now, right? So you are paying more per unit, but you're not really paying for, well, we're probably going to have this many requests, so let's have 5 app servers this time. So this changes how you think about redundancy and failover as well, because you're no longer having multiple clusters to keep things going. That's not your problem anymore. Well, it kind of is, but it's less of your problem. So it changes how you think about this. And that's what's kind of interesting about serverless for me, is basically this kind of financial model and what kind of incentives it creates. So rather than paying per application, you pay per 100 milliseconds of serving a request multiplied by the amount of RAM you use. So if you improve, say, some code to service a request in half the time, you just halve your costs. And if you can then find a better way of doing that to use half your memory, you've halved it again. All right? So in many cases, you've burned less CPU, and you've also burned less energy, and therefore you've burned less CO2. So if you're are really into performance optimization, you're a regular Captain Planet now. This is a good thing. And you might be thinking of why this talk is feeling all about optimization rather than the environment. Well, this is what I mean by being there a lot of overlap between the things we do to reduce CO2 and the things which are kind of good engineering practices. So, for example, Google and Amazon, they don't necessarily care about saving energy because they're warm, fuzzy companies. They do it because it's good business sense. And they work at a scale where the incentives to save energy are proportionally greater than us and can use more sophisticated techniques. So by using their tools like that, we kind of benefit from that. So as an example, Google, Google basically bought DeepMind, an AI company, for almost $500 million. And then they deployed the AI to work out the most efficient way to run its own data centers to save lots of electricity. Now, given that Google's second highest cost after staff is electricity, you can see why they did this. But also, they reduced a ton of CO2, which, so that's kind of a good thing for the planet as well. So planet-friendly is wallet-friendly in this case. And I don't know about you, but I don't work at any place where we have a $500 million AI trying to tweak how we run our data center. But this gives you some ideas. And I said this could be about Python. So these are some of the tools that you might actually want to look at if you're working with Python. If you're looking at platform as a service, these are the kind of common things here. Cloud Foundry, the open source platform as a service system, has a kind of auto-scaler built into it based on kind of load or usage time, things like that. Heroku, if you pay for the high-performance dynos, you get it automatic for free. But there's also kind of third-party add-ons which will just switch things off at like 6 o'clock when most people have gone home anyway. And I don't know about OpenShift, but there's a gentleman, or at least a few gentlemen behind the OpenShift stand, and I'd love to hear if there is something like this, because it feels like it'd be a really useful thing to actually have. Now, in functions as a service, the kind of blessed tool by Amazon is Chalice. It makes basically writing a function, then kind of deploying it to Amazon very, very easy. But you're kind of stuck in Amazon's wonderful golden cage, so you might not want to be really tightly coupled to Amazon. Zapper basically takes a WSGI kind of Python application, does some clever stuff with it, and lets you run it on AWS as well, but they're looking to actually be kind of cross-platform as well. Now, serverless, which is kind of seen as the new kid on the block, serverless works with Google Cloud Platform, AWS, OpenWhisk from IBM and Bluemix, and I think another thing called Funkatron, which is an open source take on this stuff. That's cross-language and cross-provider. So you might want to look at those ones as well. And also, I think all these now run on Python 3, so woohoo, at long last. So I've spoken a bit about like running servers, things you control. Well, there's actually, and like I said that because you're controlling the servers yourself, you have quite a lot of control there. But typically, you need to send data to your customers. And if you think about like this, the last section being your platform, this is like your packets. So when a request leaves your servers, you don't have much control about how it routes through the internet to reach a user. And this is a feature of the internet. It's usually a good thing. This is what means that this helps us get around censorship and things like that. However, because you don't have control over how green the infrastructure is that makes up the internet, sending data can result in wildly differing amounts of CO2 emissions, depending on where these servers are. So this map, the electricitymap.org, it's an open source project, which basically shows real-time values of all of the basically CO2 intensity of all these different countries and who's selling energy to who. So this basically will show you how green the energy is that you're using, all right? And it's in real time. It's a really cool project and runs on Python. So you can see France is super green because it's full of nukes, right? So Scandinavia is full of mountains and hills. So they've got loads of hydro, right? Which means they're green. Germany, well, where I live, we have lots of solar, which is good, but we also have lots of coal, which isn't so good. So that's why we're kind of in that kind of dirty orange color, all right? Poland has loads of coal, which is why it's awful kind of deep, 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 dark black. Likewise with Estonia up here. But you kind of get the idea, really. So if you have data going through this, it's going to affect the impact of it. So we've covered about how the energy mix in a country is one factor that affects the impact of any website that you run. But another one is actually what kind of connection you end up using to send data to people, or more accurately, what users use to connect to your services. And as this quote from Center for the Energy Efficient Telecommunications report suggests, the type of connection affects CO2. So this, I found this is kind of a leap out kind of quote when I looked at it, right? So when you see this here, it's like what? I found this really surprising when I thought this, because I thought all the energy was in the data centers, not in actually transmission, but that's not the case, clearly. And this is growing quite fast, because as we move to using mobile, we end up using way more things like 4G, all right? So you can see this graph here from like 2012, and this is like the low and the high scenario, right? And you can see that 4G usage is greater than all of the usage from just 3 years ago, and we're kind of growing at that speed, like it's continually happening. So we've got like a problem here, right? We've got we've got a very, very energy inefficient, CEO-intensive way of sending data, and we also have something of an obesity crisis in web page size these days. So you can see this kind of clear direction in travel from like a few years ago to like maybe say 2 years ago now, right? And like we're a little over 2 megabytes. I think last year we reached the point where the average web page is bigger than Doom, right? So we should be doing better than that, right? So what can we do? The thing is, people have been trying to solve some of these problems. So in the web performance community, people have started using things called performance budgets, all right? So I want my site to load this fast on this connection. Then they'll tell you, well, you've got about maybe 800K to play with or something like that. And this is a good way to, A, improve the user experience. I mean, that's the main reason they're doing it. They're going for a good user experience on a fast-loading site. But it also happens to be quite planet-friendly too, because you're reducing the amount of data being sent. And we've just established how ruinous for the environment sending loads of data over like 4G connections might actually be. So by building like a good user experience, we're also building a decent planet-friendly kind of product or service. And what's kind of cool is that these kinds of ideas, we can start incorporating them into kind of continuous integration, the same way that you might kind of put your tests under CI. So this is one company called SpeedCurve, and they basically just hit some of your pages every day, and then they see how big your pages are and how they've changed, and they'll give you an alert, like breaking the build, if the pages have either increased or gone beyond a performance budget, or they're too large or something like that. So we have tools to guard against this. And this isn't the only tool. There's an open source tool that you can run on your own software, on your own infrastructure if you want. And there's another tool called Caliber App, which was released recently, which does lots of similar things as well. So this is kind of one cool use, but these tools allow for some other clever uses. So there's a company called USwitch in the UK, and basically you visit their website and they will tell you if you can save money by switching to another provider for your energy. And they basically use tools like this to benchmark their own applications against their competitors to see how fast, so they could be faster. And at one point, they were something like 5 times faster. And they are now like one of the market leaders. That's not the only thing they did, but that would definitely helped. And if you just like Google web performance optimization, you'll see countless studies from Amazon, Bing, Etsy, correlating basically good high performance with increased sales and more satisfied users. So I found it useful to kind of think about this. I've tried to find a kind of good way to think about this, and I found one way that you can kind of frame it is like lossy changes and lossless changes. So we often make kind of lossy trade-offs in what we send to people when you do things like deliberately reduce image quality and dimensions because a lot of that data can't be perceived by users anyway, or you try to omit unused code for a faster loading site. So that's like one thing you can actually do, and that's fairly commonly done in kind of front-end circles these days. So rather than sending a whole jQuery and a whole bootstrap to someone just to give someone a drop-down, you can just do some clever techniques like tree shaking and some of the actual. So as I said, there's lots of interesting work going on in this area. And so I spoke about the previous idea being lossy, like you're omitting things as you send along. The other option is kind of lossless, right? So that's like gzipping or minifying files. So you don't like lose information when you send it, but you send it in a much more efficient fashion. And I kind of would lump, say, caching in that system, in that kind of area as well, because you're not sending data, you're not losing stuff, you're just sending, you're not sending something because they've already got it, all right? So you end up with less data and less CO2 being emitted. Can I give this back? Because I think I'm getting some kind of feedback. No, that's a bad idea, isn't it? Okay, so I've put together like a kind of grid here to show you what you might use in the kind of Python toolbox. And well, basically, there is a kind of Django focus here, but basically you can compress things as part of your actual application these days. If you have like static things, you can serve things over CDNs, like I mentioned before. And I spoke about kind of the front-end stuff, only sending the information you need to do. There's tools like ImageOptim and TrueImage, which is like the Linux version of this tool you have for local things. And this does the kind of clever tree shaking thing to only send the JavaScript you need. And if you don't want to learn any of this stuff, or this isn't something you have time for, there's all these cool kind of plugins for Nginx now, which will basically take your images, kind of optimize them, strip out all the data, and only send the correct size for something, and even do things like minify your JavaScript now. Now, You might not want to do that because it might be a little bit too magical for you, but there are options, and that's free open source stuff you can just run if you're already using Nginx. Likewise, if you're working with, say, Python, you're generating images, lots of these tools actually have options to just optimize things in there. So you can kind of have this as part of your kind of workflow when generating images now and actually realize some of these savings. So hopefully I've given you an idea that there's things you can do to affect the environmental impact of sending packets to users, and coincidentally, they almost always result in a better user experience, as pages end up loading faster and we end up with us or our users paying for less bandwidth. So if there's one takeaway I want you to take from this talk, it's this: making a site work better for the planet is pretty much the same thing as making it work better for the users. So the chances are many of you in this room already have spent years becoming black belts in planet-friendly web ninjutsu. Here then, Neo, like, you already know Kung Fu. This is like, we're already here. So this is kind of what I'm going to round this off with. Remember those scary graphs I mentioned at the beginning of this talk, and how basically every industry needs to change if you want to stand a chance of staying inside this planetary budget of 2 degrees? As professional developers, we'll need to know what these changes look like for our industry too, especially given that IT is being seen as one of the great hopes to actually have this greener, more sustainable future. So I aimed in this talk to give you a better understanding of where what we do fits into the global picture, and how some of the stuff you might already be doing might be having an effect on the environmental impact of sites and apps you create. And I hope in your day-to-day jobs, you'll see how things you are already doing can help you make the sites you build more planet-friendly, but also cost less and provide a better user experience. You might do it because you feel strongly about the environment like me, or you might do it because you like looking awesome in front of your boss. The key thing, as developers, we don't need to choose. For us, they're the same thing. And I think that's pretty much it. That's the main thing I want to leave with you. If you know, anyone know this guy? No? Yes, one person. Awesome. The power is yours. Okay, no one would have got that if you're less than like 30 years old. Damn it. But yeah, that's me. Thank you very much. I'm happy to answer questions. I've spoken very fast. This deck is online here with all the links and all the numbers there, and you can also join a mailing list where I'm basically sharing what I learn as I go through this. I'll be very considerate with your time, so only like 1 email a month or so. And yeah, I'm working at Thermondo in Berlin. Come join me, because we care about this stuff, and like, it's our rallying cry, part of our vision. Yeah, that's it.
Perfect. Thank you very much. We will just jump into Slido because we have some questions there. Oh, question 1. Do you consider sunlight as renewable energy?
Okay, I'm going to give you the fast one. The embodied energy is quite involved, but so the embodied energy is all the energy needed that goes into building the panels in the first place. It's got much, much better, and it's probably one of the best options we do have, and it's got cheaper, faster than almost anything else. So yes.
Thank you. Do we have some more questions from the audience? Okay, yeah. Okay.
Also, the sun isn't technically renewable. It'll eventually die, but we'll probably won't care by then, right? Or maybe we'll be somewhere else. Was there another question? Sorry.
Do you have idea, let's say, what's the ratio between running production code and doing continuous integration and stuff?
So the question is...
which portion of compute and resources continuous integration and development process consume? Let's say comparing it to running production code for users.
Do you know, I don't know, because it depends if you're running like this is the whole thing about trying to work out the carbon footprint of anything. It gets ridiculously complex so quickly. So if you're running like a big Jenkins box, all right, then that's your impact, however long that's running. So it's energy draw of that server 24/7 compared to, compared to the production setup you have. So if you've got like loads of big servers running in production, then yeah, you might have more. There isn't really a kind of, I'm afraid I'm going to cop out and give you it depends as an answer. But if you are not paying for servers, there is a much more direct incentive to, well, basically you get to keep all the savings rather than having it stuck in a server. Does that help give you a kind of non-answer to your question? Sorry about that, but yeah. So,
okay, thank you. And we have one more. Yeah.
what are your views on the Bitcoin farms, the energy that they use? Is it like a big deal, and do you think it will become a big problem? Can it be reused for heating or something like that?
So the question is about the waste heat from data centers, like server farms? Is that the question?
Yeah, the heatings and the electricity, basically just to mine Bitcoins.
So there are a few kind of interesting ideas that are being that different companies are trying to do or use this, right? So there are some places in Europe which basically use the waste heat to heat like nearby blocks of flats. Or I've seen a data center in Cork where they use the waste heat to basically help ferment beer, right? So that's the kind of nice CO2 emissions I want to have, right, in my beer, right? So there are some kind of clever things that people are actually doing with this, but yeah, you're going to have a problem. That's quite difficult to get around. But and this is why, I mean, okay, I could get quite techie on this. There's a metric called PUE, which is practical usage effectiveness, and that basically just decides how effective any data center is, like how much energy is used to keep it cool versus actually serve things. And as things have got more efficient, they've got better. It's an unsolved problem right now, and people are coming up with better ways of using the heat. But a lot of the time, they just throw money at it and try and keep things cold, or they run things in cold places, like say Iceland, or Facebook having data centers in Sweden or Denmark. No, definitely Sweden. Sweden's colder than Denmark. Or Microsoft, where they are running data centers in the water, which they're brave, like water and electricity. I feel a bit uncomfortable about them being in the same space, but they seem happy with it. So yeah, it isn't a solved problem.
So the problem with reusing the heat is just the technology?
Yeah, and also like transmitting it, I suppose. That's it. I mean, I'm not an expert in heat transmission for things like that, because I don't know, it doesn't affect me on a daily basis, whereas the kind of development stuff I can definitely use. But I would love to find if anyone does have some better ideas about this, because I'm a media student by training, so as soon as people start throwing numbers at me, I'm going to have a hard time following the thermodynamics of that.
Okay, thank you.
Perfect, thank you. Do we have some more questions, or should I go back? No, this was not wise. Thank you. Okay, so thank you for the answers to all the questions we had. And thanks for the questions. So, yeah, let me thank you one last time.
Cool.
Yep.
Thank you, everyone.